This problem is Leetcode uh, 2944 minimum number of coins for fruits. It is typical DP problem, and it's belong to today code Leetcode coding contest 118, weekly coding contest 118. So problem statement like you are at the fruit market with a different type of exotic fruit on the display. You are given one index array price, which price I denote the number of coin needed to purchase I. That means they will give you one array, and ith index value will represent the what is the cost for the buy ith fruit. And if you purchase the ith fruit price I coin, you can get the index I fruit for free. That means if you have purchased fifth index fruit, then next five fruit you will get free. So note that if you can take just J for free, uh, you can still purchase for price J coins to receive a new offer. That means uh, you have option. If you are getting sixth after buying, suppose after buying you are getting the fifth fruit in free, but you have two option. Still you can purchase sixth fruit by getting more offer. So that's the problem. So return the minimum number of coin needed to acquire all the fruit. So you have to return what is the minimum number of coin need to purchase all the fruits. So suppose we are having we are having array 2 fifths 6 12 3. So this is the array of length 5. So basically it is the first index, it is second index, it's third, it's fourth, and it's fifth. We are taking one index because in question it's clearly mentioned that it is one index array. So this is the first fruit and its price is 1. This is second fruit and its price is 5. This third fruit and its price is 6. This fourth fruit and its price is 4th, and this fifth fruit and this price is 5. So suppose we are taking second we are buying second fruit. So if you buy second fruit, you have to pay the price of second fruit, and next two fruits, third and fourth place fruits, you can get free. But if you want to buy that fruit also, then you can buy. The benefit of buy next fruit is if you will buy fourth fruit, you will get the option to take next four fruit in free. So you have to check it is beneficial to buy that one fruit, and or you it is beneficial to getting that fruit in free. So but if you not have a option to buy if you have not option to take that fruit in free, then you have to buy that fruit. So suppose we have buy second one fruit, so third and fourth fruit we can't we have option to take in free, but for fifth fruit we have to buy, because by buying second fruit you have to the option to take just two fruit in free, because their index is 4, and in question it is mentioned that if you buy ith fruit by paying a price of I, you can get next I fruit. That means the index of that fruit, next index of that fruit you will get in free. Suppose index of that fruit is 5, so next 5 fruit you can get in free. So it's typical EDP problem. For each index you have two options. Either you can buy that one or you can not buy that one. And uh, with some constraint, if you have if uh, uh, if you use all the free fruit validity, then you have to buy that fruit. So let's jump to the solution. Submission parts, and it's my submission. So first the first uh, we are creating two deep 2D DP for 1001 and 1001 length, because the length of maximum. So here is fun function is taking two argument I and D and vector price because we have to keep track of what is the price of each index. So I represent at which place we are having current now, and int D representing how many next fruit we can get in free. So if you have no option to get any you have if you have no option to get any next fruit in free, then we have to buy that one. So if you will buy that one, then uh, index will increase by 1, and next I plus 1 we are adding plus 1 because it is one in question it's mentioned that 1 plus indexing. So 1 for 1 plus indexing we are adding plus 1. So for next I plus 1 fruits we can get in free, and for that you are buying, for that we are paying price I money. And if you have option, if d is not equal to 0, that's mean we have option to get some fruit in free. So for that you have two option, either we can buy that one or we can't buy that one. So if you will not buy that one, then we have to pay some money, and if you'll buy that one, then you have to pay some money, and if you'll not buy that one, then the next fruit that we can get free will decrease by 1, and index will increase by 1. And here we are using 2D DP array to removing repeating calculation. If it is not first we will make a 2D array of this much size, 1001 because the length of maximum array is 1000 plus 1 because it is one base indexing. So first we will initialize the DP with -1, and we will check if the value of that value is not already calculated. If value is already calculated, then we will return that one. If it's not already calculated, then we will calculate that one and we will store in to the DP array. So it's basically typical DB problem, and it's easy one. So this is the code for the same.